Okay, so let's look at the ocean currents again, just with the available animations or videos online. This is from NOAA, I think, but as I said, we always pick those that have permission to be used. There's some funny sound here. Maybe I should turn it down. So there we go. The sound is gone, and oops, I cannot stop the sound. Yeah, there we go. We are looking at each ocean here, so let's bring up the so this is the Pacific Ocean. We talked about the south equatorial current, north equatorial current. For some nice dynamic reasons, there are also currents called counter currents, which go against the winds. I'm not able to stop it here, but let me come back again and stop it and then explain that wind. The Indian Ocean is shown here again, but remember that the directions change. So this is shown for the summer months when the southwesterly winds are blowing, so the Somali current is going north. There is a current coming down here. There is a north equatorial current in this season, and there are equatorial countercurrents and south equatorial current here. There is something called the Agulhas current, which breaks into something called the retroflexion, so it goes back towards the Indian Ocean here, and some goes around, called the Agulhas outflow or leakage, and there is a Benguela current. The main thing you want to remember is that the western boundaries of the ocean have something called western boundary currents. They are strong, narrow, warm currents because of dynamic reasons that happens. So you have the Somali current here, and of course in the winter you will have the Somali current going south because the winds are from the northeast. The Agulhas current is always going in the same direction. Benguela current, which is the eastern boundary current. What is the eastern boundary? It is the western boundary of Africa, but it's the eastern boundary of the Atlantic Ocean. So this is the South Atlantic Ocean, which has a strong western boundary current here called the Brazil current, and Benguela current is the cold current. Similarly, you have the Canary current. There is a cold current on the eastern side in the northern hemisphere, and on the other side it has of course the can I start it again? Okay. I think it needs not the pointer but the cursor to be able to make it move. So if yeah, there we go. So I will just use the cursor to point this time. So let's stop this here. So you have the south equatorial current and the north equatorial current in the Atlantic Ocean, also similar to the Pacific Ocean, because both of them are similar northeasterly trade winds and southeasterly trade winds. Why do we have then this something called a counter current? It's called a equatorial counter current. So here is the Gulf Stream. The Gulf Stream comes out and goes into the northern Atlantic here. The eastern boundary current is the Canary current. The Gulf Stream is complicated. It has multiple branches going here into the Gulf of Mexico, and then coming out of this region here between Florida and Cuba, and becoming the Florida current, and so on and so forth. But the countercurrent is a fairly simple thing. As the winds push the water westward, so northeasterly trade winds push the water, they pile up here against the coast, right? As the waters are being pushed westward and they are moving west with the south equatorial current and the north equatorial current, they pile up against this coast here, and then the water flows down the hill. And that's why even though winds are going this way, both north equatorial and south equatorial current, northeasterly and southeasterly trades are pushing this way, the countercurrent goes into the winds, and that's the same thing in the Pacific as well. Okay, So you can see these complicated currents. This is the Gulf Stream here, and you have the deeper currents going south, which we will not worry about. The Peru current here in the south is the cold eastern boundary current of the South Pacific Gyre, and the California current, California is right here that we talked about before. This is called Baja California. This is Mexico down here. So the California current is the southward flowing cold eastern boundary current. There are small gyres here like the Alaska Gyre, and let's go a little bit east, a little bit more west. Now you can see that there is a there is a strong let me just look at it again so that you remember them. And you can see that when we get into the Pacific, we will see, let me stop here. So you can see the counter current again, south equatorial current again, and north equatorial current again, and you have the cold Canary current, which is the eastern boundary current. The strong, narrow, warm western boundary current here is called Kuroshio, as I said. Here it says Kuroshio current, but it's not exact, because Kuroshio in Japanese means black current. So Kuroshio already has current in it, and there is a southward flowing deeper, colder current coming south here. So the gyre that we looked at is here. There are other currents to the north that we didn't discuss so much. Remember, the westerlies are here, which explain the eastward current to a large extent, and there are easterlies which explain these currents. So the Kuroshio, it's a black current basically because western boundary currents tend to be warm waters going north. They don't have many nutrients. I'm adding something here, so you have to be careful. If you're older, you probably realize what we mean. Ocean waters have nutrients like nitrate and phosphorus and iron and other things. If there is enough light at the surface, they can produce photosynthesis and food for the fish. So phytoplankton, plankton means something that is floating and cannot swim. Phytoplankton is an algae in the ocean that photosynthesizes with light, and zooplankton is something that eats the phytoplankton, and then small fish eat the zooplankton, bigger fish eat small fish, and so on, and you have a whole food web or a food chain in the ocean. Kuroshio current doesn't have any algae, any food for zooplankton, so there is not many fish here. Obviously, Japanese love their fish. They eat sushi. Most of their diet is fish. So if there is no fish in the water, they are not happy. They call it the black current because it doesn't have any fish. Okay, so let's go towards the Indian Ocean and discuss this a little bit more. Indian Ocean to the north has these reversing currents. So as we were saying, it has trade wind like, so it has southwesterly winds here which force a boundary current here, and that boundary current comes back south here. So this is a western boundary current. Similarly, there is a western boundary current here and the eastern boundary current here, but you can see the Bay of Bengal has a little gyre, the Arabian Sea has a little gyre. The two oceans are connected by the north equatorial current. Actually, this is a little bit wrong, because when the southwesterly winds are there and the Somali current is going in this direction, there is a current actually going from west to east that is called the monsoon current, whereas in the winter, when you have winds coming from the northeast, the Somali current goes south, and then you get, remember the northeast winds look like a northeast trade winds, so they create a north equatorial current here and a western boundary current here that actually goes south. You can go find these in my oceanography course, which is discussed in more detail. The southern Indian Ocean, the Indian Ocean Gyre, has an eastern boundary current called the West Australian current, and has a south equatorial current and a counter current because water is piling up here and flowing down, and then you have a western boundary current here, the Agulhas current, that's going south and around, or some of it is going back this way. So Indian Ocean is very special in that sense. currents. It is also special because these gaps here between New Guinea and Indonesia from the Pacific Ocean into the Indian Ocean push some waters coming through here. That's called the Indonesian through flow. Through flow means a flow is coming through here, which creates some interesting currents here that are different than the other current oceans like the tropical Atlantic and Pacific Oceans. So this is different. This is also visible in the thermohaline circulation, as we will see in a minute. The Antarctic region here with the Southern Ocean to the north is different again because it's a channel. There is a big gap between Africa and Antarctic continent, between Australia and the Antarctic continent, and if we look at the Pacific and Antarctica, there is a much narrower gap between the South American tip and Antarctica. That's called Drake Passage. So you can see this gap here is much smaller. It's called a Drake Passage, but nonetheless there is a pathway, so these currents go around and around. These things matter because think about now all the waves in the ocean. So obviously when you have winds blowing on the ocean, you expect the waves to get created, but also the winds are putting energy into the ocean. When winds are dragging the ocean and creating currents, that's energy going into the ocean, right? So if northeast trades, for example, begin to pull the ocean this way, then when they reach the other end, they run into the Asian continent here. So there is a boundary. So wind energy cannot go into the Pacific Ocean anymore because it's blowing from the North American coast, let's say here Central American coast, to the Asian coast. So only about 5 to 10% of the energy from the winds at the surface actually goes into the ocean. So even though there are waves coming at the coast all the time, that's only a small part of the wind energy that is converting into waves. Okay, but here it's different because the Southern Ocean goes round and round. That means winds can keep churning the ocean round and round. So much more energy goes into the ocean in the Southern Ocean. Much more means it may be 10 to 30% instead of 5 to 10%. So this is a very, very stormy ocean. People don't go there very often, especially in the winter months, because it gets too stormy and too dangerous. So people just fly onto Antarctica and stay there for a long time to make measurements and observe the things. And there are geopolitical reasons why even a country like India has a permanent camp on the Antarctic ice glacier. Okay, I haven't still explained what a glacier is, but you keep listening and we will come back to glacier in one of the podcasts later on. Okay, so I'll stop this ocean current podcast here. Maybe we should look at this also, since this is also the same thing, just shown differently, but it's again showing the same thing. This time it is south equatorial current, north equatorial current, equatorial countercurrent. This is called the East Australian current, which is the western boundary current. We talked about Kuroshio before, talked about the Indian Ocean before, so it just repeats what we have already seen. I just included because I found it, and it's basically the same thing created again by NOAA, but it's now giving a little key saying these are warm currents, these are cold currents. This is a cold region at high latitudes. This is a cold current, the Benguela current, the eastern boundary current in the Atlantic, South Atlantic, Canary current, which is the eastern boundary cold current in the North Atlantic. We have the Gulf Stream and the Brazil current, and so on and so forth. So let's leave this here, just re-emphasizing the points. We'll come back and look at maybe a couple of more podcasts which will just re-emphasize the points we have already made. Okay, so I hope it gives you a sense. I'm just explaining and adding a few more points about winds putting energy into the ocean. So see you in the next podcast with a bit more about ocean currents.